So welcome to lecture series on design and analysis of algorithm. In this algorithm, we are going to see about the max flow problem. So before going into the topic, let us discuss about what a flow is about. So consider a scenario. If you look at this picture depicts the road traffic system. So here, flow indicates the number of vehicles that can pass through a particular road. So each path or each road will have a specific capacity. So the flow represents the number of vehicles that can pass through the particular path. So let us take one more example. Yes, this is very good example for representing the flow. So here you can see the pipeline. So inside the pipeline, the amount of water flowing is represented using flow. So here if you see, the capacity of the pipe differs from the flow. So capacity is the maximum amount of water that can pass through or that can flow through the pipe represents the capacity. So flow, it is not essential. This flow should be equal to the max capacity, right? So at a particular time, the flow may differ. So sometime the flow will be maximum, sometime the flow can be minimum. But capacity is something like uh, maximum flow. So capacity represents the maximum flow. So another example for flow is water or oil or any liquid that is flowing through a pipe. So fluids in a pipe is best example for flow. Third example is in computer currents in an electric circuit. So if you take an electric circuit, the current passing through a particular circuit is also termed as a flow, amount of current that is passing through the particular copper strip or particular circuit can be described using the keyword flow. So take one more example. In a computer, so this is a computer network. So the internet information is shared or transferred in terms of packet. So the number of packets passing through each path is termed as flow of packets. So these are various examples of flow. So packet traffic in a computer network can also be considered as flow. So this is a flow network. Here the circle in blue color represents the node and the arrow mark represents the edges. So uh, the beginning flows. So here, if you see the first circle, the flow starts from there because the arrow mark is pointing towards the forward direction. So from the first circle, the flow will start and it will go to the second node. So this is forward flow. The flow happens in the reverse direction, that is reverse flow. So F/E is for each edge, we will have a weight, right? So that weight represents the capacity of that particular edge. So F represents the flow of that particular edge. So you have to note that this flow should not exceed the capacity. So a direct flow network is a directed graph where each edge has a capacity and each edge will receive a flow. So the amount of flow on edge should not exceed the capacity of the edge. So this is not possible. So you remember the pipe example. So the amount of water flowing through the pipe should not exceed the capacity of the pipe. The same thing is applied here. So the flow on the edge should not exceed the capacity of the edge. So these are some of the constraints. The flow must satisfy the restriction that the amount of flow into a node should be equal to the amount of flow that is coming out of it. So unless it is a source node. Here, if you see this graph, A node is called as the source node. So A node has only outgoing edges. It does not have any incoming edges, which means this particular node A, which is the source node, does not have any incoming flow. It has only outgoing flow. So source node will have only outflow. So in this case, the incoming flow will not be equal to outgoing flow. This is applicable only for source node. So source is a vertex with no entering edges and destination is a vertex with no leaving edges or vertex leaving edges. So here we have mentioned the weight for each edge, right? So like from A to B, there is an edge and its weight is 10. So this weight represents the capacity of that particular edge. Or so here from A to B, if you want to mention a flow, that flow should not exceed the capacity, which is 10, which is the weight of the particular edge. So so far we have seen what a flow is and we have seen what a flow network is. Hope you are understood Hope you understood the concept behind the flow network. There are two main constraints in case of flow network. One is the incoming flow is equal to the outgoing flow. If எவ்வளோ incoming flow இருக்கோ அவ்வளோதான் outgoing flow இருக்க முடியும். So that is main thing, and this is not applicable for source node. Second thing is the flow of each edge should not exceed its capacity. So that is the second main constraint. So in the next PPT or in the next lecture, we will discuss about the max flow problem. So this max flow problem is especially applied for flow networks, which is an optimization theory problem. It is used to find the feasible flow through a single source and a single sink flow network, which is maximum. That is, it is used for determining the maximum flow in a particular flow networks. So we will meet in the next lecture series where we will discuss about the max flow problem. So this max flow problem will be solved using an algorithm called as Ford-Fulkerson algorithm. Thanks for watching. Continue watching. We will discuss about the Ford-Fulkerson algorithm in the upcoming slides or upcoming PPTs. Yes. So we can identify A